Let's talk about the next two operations. We've got B and C to go. We just pointed out that A and D, the changes that happen after the trig function, had a vertical effect on the graph. They produced vertical changes in the graph. So presumably, since I pointed that out, C and B are going to have some kind of horizontal change on the graph. We haven't observed that yet, but that is what we are about to observe. So let's just put that in writing. The C and B, we're going to see some horizontal changes in the graph. So the next one we want to look at is a little bit easier to look at is C. What's going to happen to when we change the value of C? So I've set everything to our default. Our multiplication changes are at 1. Our addition changes are at 0. And I'm going to start changing the value of C. What's happening when we change the value of C, aside from the fact that I picked some weird numbers for this one? Is the amplitude changing? No, that's A's job. Is the middle changing? No, that's D's job. Is the period changing? Let's pause and find out. So here's the top point, and here's the next top point. And here's the next one after that. So from negative 5 pi over 6 to 7 pi over 6. I had to do fractions, didn't I? Jerk move on my part. Let's go in and change this back to negative 4 to 4 with a 0.2. Here's a top at negative 3.683. Here's a top at 2.6. It's kind of hard to see the pi over the 2 pi. Change that. Here's a top at negative pi over 6. There's a top at 5 pi over 6. So the distance between those 2 points, that's the period. Negative 7 pi over 6 to 5 pi over 6. Negative 7 to 5, that's 12, a difference of 12. 12 times pi over 6 is going to be 2 pi. So notice that the period is still 2 pi. If I go from the middle going up on the sign to the middle going up to the next middle going up, it's still negative 7 pi over 6 to 5 pi over 6. Everything, I picked these points because I knew they would work out. Let's go from another set of points. If I go from the middle going down to the next middle going down, I got negative 2 pi over 3 all the way up to 4 pi over 3. That's a difference of 6 times pi over 3. 6 divided by 3 is 2. That difference is also 2 pi. And if we check on the sign, let's say at these bottom points, here's the bottom is at, oh, really? You're going to do that to me, Desmos? Desmos, you're going to do that? You're going to be like, I can only do the decimal equivalents. There's 5 pi over 6 to 17 pi over 6, a difference of 12 pi over 6, otherwise known as 2 pi. So the period is not changing. All that's happening is the graph is shifting side to side. So C moves the graph from side to side. Maintains the shape, but moves the graph from side to side, just like D maintains the shape, but moves the graph up and down. It's really jumpy. It's like we have a bad video card. Does this look like a bad video card, an overheating computer, or a crappy internet connection? I can't really say. My computer has all three of those things, so I'm not going to be able to determine which one it is. If I stop D affects the middle, we know that. What's happening is we can see the graph going side to side. You can see the graph going side to side. Amplitude didn't change, period didn't change. It's like the starting point. The way that we want to think about it is that the starting point is changing from 0 to somewhere else. Notice that if I pause C at some point, oops, I didn't want that to start. Calm down. If I pause this C, value of C at some point, instead of the top being at 0, the top is over here at 2 pi over 3. So we can think about this as the starting point moves off of 0. C is moving the start off of 0. Let's put a vertical line. Turn the middle off. Let's put a vertical line along with C. When C is 0, the vertical line is at 0. But when C goes into motion, that 0 line starts to move back and forth. So it looks like C is shifting the graph left and right, a horizontal change like we expected. And the part of C that shows up is where that starting point is going to be. It moves the starting point off of 0. So that's how we're going to think about that one. Changing Z moves the starting point off of 0. It looks like changing the value of C moves that starting point off of 0. Instead of the top of the cosine being at 0, the top of the cosine is somewhere else. We can think of this as shifting the graph side to side. So what's happening is we're shifting the graph horizontally, just like changing the middle shifts the graph vertically. We maintain the shape, we just move it back and forth or up and down, back and forth with the value of C, up and down with the value of D. C had no effect on the other stuff. C did not have any effect on the amplitude, where the middle of the graph was, or the period, how long it took to get through one cycle. Gosh, I wonder what B is going to do. Moreover, when we look back at the graph, I left it running. It's going to be all tired now. Moreover, let's see what here C is at 3.14. C is equal to pi. That top point is at pi. So C is the new zero. C is the new zero of the start. One thing we want to note is that when we've written out this, when we wrote this out, so we wrote cosine, we have plus D, but in the equation we write minus C. So it looks like I have a subtraction of C. So minus C, so when it says minus pi, we go to the right pi units. But when I said plus 2 at the end on the outside, it went up 2. So it looks like the shift, the horizontal shift, has the opposite sign of what direction we would expect. When we see minus pi, we went to the right pi. But with the vertical shift, when we see plus 2, we went up 2. But that's reflected in how we write our basic cosine, x minus c. So we want to think not of this minus c out here. We want to think about what will make this equal to 0. What will make x minus c equal to 0. That's where our new 0 is going to. So back over on the graph. When c is equal to, when the top is here at negative pi over 2, c is negative pi over 2, we can think of that as negative pi over 2, or x minus a negative pi over 2. So in the equation, it would say x plus pi over 2. And that would be a shift to the left of pi over 2. Any questions? So C and D, the shape of the graph isn't changing. We're just changing the location of the graph. So jumping. A little bit better. Any questions? Comment? Snyder? What's going to happen when we change B? What's the only thing left to change? So A changes the amplitude and like which starting point we use. No effect on the middle, the 0, or the period. D had no effect on the amplitude, the 0, the start, or the period. C had no effect on the amplitude, the middle, or the period. So what must B be in charge of? Only thing left is the period. So it looks like B is going to change the period. One thing that we do want to point out here is that D and C both shifted the graph vertically and horizontally. So another thing that we can observe is that they have the same operation attached to them. So it looks like addition and subtraction produce shifts. Addition before is horizontal shift. Addition after is vertical shift. The word we'll use to describe what multiplication does is stretch. When we change the amplitude, it's like we're stretching the graph. So let's go over and change the value of b and see what happens. No surprises here. We see this graph springing back and forth. We're doing multiplication, and the multiplication happens before the trig function, so we see a horizontal change. Notice that the amplitude is not changing. Notice that the middle is not changing. And our starting point is not changing. What is changing is the period. For different values of b, we get different values of period. So our default period is 2 pi. That's from the top to the top here. Let's change the value of b to 2 and see what happens. When b increased, what happened to the period? When b went up, what happened to the period? The period got smaller. Instead of the period being from 0 to 2 pi, the period only went from 0 to pi. The period when b got turned to 2, the period got cut in half. If we go all the way out to 2 pi, we get 2 cycles. If we change b to 3, oh, awesome, it'll let me do it. If we change b to 3, one cycle is going to be 2 pi divided by 3. So the next top is going to be at 4 pi divided by 3. Then the next top will be 6 pi divided by 3, otherwise known as 2 pi. We got 3 cycles in one circle. Two things that we want to observe. It looks like the period is just going to be 2 pi divided by whatever the value of b is. We can think of b as how many cycles we'll get in 2 pi. We can think of b as how fast we're going around the circle. When b is equal to 2, we're going around the circle twice as fast. The number of cycles that we're going to get inside of 2 pi. If I change b equal to 4, one cycle is 2 pi divided by 4. So I'm getting 4 cycles in 1 2 pi. We're going around the circle twice as fast. When b gets smaller, we'll expect the opposite to happen. When b gets smaller, the period will stretch out. So let's drop b down to a half. So now that b is down to 1/2, we see that one cycle takes 4 pi. We're going at half speed, so we only get half of the cycle inside of 2 pi. We'll go around the circle twice as slow. Any questions? Of course not. It's like 2:30. No one will have a question now. I'm like, oh, Leach often ends class on or around, sometimes even before 2:30 on the good days. But I don't want things to last longer, so I'm not going to ask any questions. I could be like, oh, here's the fundamental theorem of finitely generated abelian groups. You're going to have a quiz on this online tomorrow with no help. Any questions? And you'll be like, oh, nope. I will worry about that shit tomorrow. Which is fine. If you're worried about us being almost done, we are almost done. So notice that when B increases, the period shrinks. Think about B as how fast we're going around the circle. So when B decreases, the period grows until we get to 0. What happens when we get B equal to 0? I got one more step. Right now, my period is at 2 pi divided by 1/10. So 2 pi divided by 0.1 is 20 pi. One cycle is costing us 20 pi. I can't even zoom out. I'd have to do an unbalanced zoom. What happens when B is equal to 0? Yeah, cosine is equal to 1 and sine is equal to 0. Because I'm doing cosine of just 0. Cosine of 0 is equal to 1. Sine of 0 is equal to 0. If we think about how we are not going around the circle, we could think of it that way. We're not going around the circle, we're staying in one spot. We could also say that one cycle is taking an infinite amount of time. That's a dangerous way to think about it. In the future, y'all are going to be calculus students and you'll be able to talk about shit like that. But for right now, you can't be like, oh, the period is just infinite. Because we divided by 0, so we get infinity. At this point, you don't get to do that yet. The math cops come to arrest you. You know what I'm talking about, math cops? Math cops, math cops. What you're going to do. What you're going to do when you divide by 2. That wasn't a very popular job. I'm not surprised you haven't heard it. What I will leave you with, the question I will leave you with is, what's going on when B goes negative? That's the question. So that's the thing. B is adjusting the period. The period is equal to 2 pi divided by B. We saw that on Desmos when we set B equal to 3. We saw that one cycle was 2 pi divided by 3. So the period is 2 pi divided by whatever B is. When B is equal to 0, everything is taking an infinite amount of time. That's a great way to think about it. You can do it this time if you walk out in the STEM center and be like, oh yeah, the period is infinite. Other teachers are like, whoa, whoa, whoa. Where did you get this stuff? Then you'd be like, oh, leave. Then they come knocking on my door and it's a pain in my ass. They don't. Just say it becomes cosine 0 and sine. We're not moving. Our speed is 0. All right, that's going to do it for today. Think about what happens when B goes negative. What's going on with B going negative? That's going to do it for today. I will see you all on Monday. Everybody have a good weekend. And thanks for playing. Okay, have you done the claim account? Have you followed those instructions? And you've tried to reset password? I have an alternate set of instructions that we can try, but and so we'll see if that works. So if you send me an email reminder, then I'll remember to send you the instructions.
I would like to apply a print of this online. Is that available? We will not be as.
No, no, that counts.
Mhm.